Hello everyone. In this video we are going to see about the fifth program in the series, which is the Fibonacci prime series. Okay, so first of all we should know what is Fibonacci number, and then we should know what is a prime number. And this function uses the function concept. Okay, a function concept is used in this program. Here now let us see one by one. First of all, about the Fibonacci series. Fibonacci series is named after the person Fibonacci, and here the number series goes like this. Initially we take the number as n1 is equal to 0, and then this is the first number, n1 is equal to 0, and this is the second number, n2 is equal to 1. Then what we will do is we have to add the previous two numbers to get the third number. So that is the concept of Fibonacci series. You can see here, this is the 0, that is the first number, 1 is the second number, 0 plus 1 is 1. And this 1 is the second number, and this 1 is the third number, then this 1 plus 1 is 2. Likewise, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and this series goes on and on. In this program, what you are going to see is we are going to generate this series, and also we parallelly are going to check about how the process is going to find the next series. Okay, now in that also we are going to find whether the number is a prime number or not. So that is the process here. So we have two functions here. One function will decide the Fibonacci series, and the second function that will check whether the given number is prime or not. So we have two functions over here. And prime number, what is prime number? Is a number which is divisible by only by 1 and itself. That is the prime number. For example, 3 is 1 into 3 is 3, no other number is divisible. 1 into 5 is 5, likewise 1 into 7 is 7, and so on. Okay, so now here next one is the composite number. What is composite number? Is the number which is not prime is the composite number. That means a number which is divisible by 1, the same number, and also by some other numbers is called as a composite number. That means this number has many factors. For example, 4, 6, 8, 9, 10, 12, 14, etc. So 4 is 1 into 4. Beyond that we can also have 2 into 2 is 4. Likewise, 6 is 1 into 6 is 6. Also we have 2 into 3 is 6. For 8, 1 into 8 is 8, and for also 2 into 4 is 8. So likewise there are many factors more than the number and 1 itself. This is the composite number. Now our program is we are going to generate Fibonacci series, and then from in that series we are going to find out whether the number generated is a composite number or a prime number. Okay, so now this is how the program starts. While the program starts, actually here the function concept is, once you are writing a program using the function, we have to first define all the functions you are going to use. In this program we are going to use two functions. One is prime check, which is going to check the number is prime or not. That is the okay. And the second one is Fibonacci series, which is the function which is going to check whether the given number generated is going to generate the Fibonacci series. Okay, and now here the previous one, that is the main program which is generating the Fibonacci series using the function Fibo of n. Okay, then this is the output of the program. So let us see the logic of the program. Okay, so now initially as usual we have the include stdio.h and include standard lib.h. Here using the header file standard lib.h to say we are going to use the library function. So Fibo is one function and prime check is other number. So since we are going to use the functions, we are using the library standard stdlib. Okay, now coming to the next line of the program, using namespace std means we are using the standard namespace for the variables we are going to use. So let us see this function prime check. What does it do? This number, check whether the given number is a prime or not. I already told the logic. A prime number is a number which is divisible by 1 and itself. So we'll start. Now the function is void. Prime check is the function name. Int a is the parameter. A is the parameter. Its type is integer. Prime check is the function name and the function type is void. Void means it returns nothing. Okay. Now open brace starts the function and this close brace closes the function. Okay. So now we are going to use one variable called integer j. Integer int space j. Integer j. J is one variable we are going to use in this function. Okay. Now here first we are checking first for initially 0 and 1. We declare 0 and 1 are neither prime nor composite. We just leave it. So just whether the number is 0 or 1. If a is equal to 0, this double equal to is a relational operator. Normally a equal to 0 means assignment operator. This is a relational operator. A equal to 0. This is then pipeline symbol is R. Logical R. Okay. So now R a is equal to 1. So if it is 0 or 1, just to see out display on the screen, the number is neither a prime number nor a composite number. Else means it is other than 0 and or 1, which means it starts from 2. It starts from 2 and it keeps on incrementing. Okay, it's 2, 3, 4, etc. So we keep on creating the numbers and then we are going to check whether the number is composite or not. Okay, so if it is composite means there is no, the remainder will be equal to 0. Okay, that means it is divisible by some number. It means it is divisible by some number. Okay, so now here we are using the for loop. This for loop, what does this for loop says is for j is equal to 2. Why 2 is already 0 and 1 is over. We have checked the 0 and 1. We have to start from 2 and j less than a. J less than a means we are going to find the number till a. Okay, so now for example, if it is now a becomes, now it is a is 0 and a is 2 and then a becomes 2, 3 and so on. Okay, now this j variable is used for incrementing and a is the given number. Okay, so now we divide this number whether it is a composite or not by dividing by all the numbers. So for divide by a modulo j. This modulo is the operator which gives the remainder after division. If it is 0 means it is fully divisible. That means there are some factors. So we are saying it is a composite number. Break will make the loop come out of this. That is the use of this break statement. Okay. So here when it is a composite number, when it is divided by the particular variable, the remainder will be equal to 0. That means nothing will be left out. If it is prime number, the numbers will be left out. If it is composite, composite means it won't leave a remainder. The remainder is 0. Okay. Now, so now this for loop is over by this C out, and but we are going to check whether it is maybe also prime. And the logic is we generated a Fibonacci series. Initially 0 and 1, it is neither composite nor prime. Now we are going to start from 2 onwards, and for divisibility there is no remainder is equal to 0 means the number is composite. Otherwise, if a is equal to j, a is equal to j means the number is the same as the divisor. Then we can say it is a prime. So the prime number definition is a number is divisible by n1 and itself. So it is a prime number. So this prime check totally checks out whether the input number is a prime number or a composite number. So this is the function called prime check. Now let us go to the next function, next part of the program, which is the next function, Fibo function. This Fibo function is the function which is going to generate the Fibonacci series. Here now, Fibo is the function name, int space n, this is the parameter of this function, and void is the return type. So initially we assume int a is equal to -1, B is equal to 1, C is equal to 0. Why minus 1 is we are going to start with the 0. So minus 1 plus 1 is equal to 0. Since we are going to sum up previous two numbers to get the third number, we are making the previous two numbers as minus 1 and plus 1 to get the initial number as 0 as the initialization point here. Okay, so now we are going to use the for loop to check whether for int I is equal to 1, I less than or equal to n, I plus plus. So the for loop syntax is you have to set the initial variable, check for the condition, and you are going to find the increment or updation, and then you have to print out cout endl means it takes to the next line. All the printing takes place one by one. You see here we'll know this the format 0 1 1 2. So one by one, in order to make this one by one, they are using this endl statement over here. So now C is equal to A plus B. What is C? C is then output variable, which is 0. What is A? A is minus 1. What is B? B is plus 1. So this will generate minus 1 plus 1 is equal to 0, which is the first number of the series. So C out C. Immediately when the number is developed in the series, it is checked for the prime number. This is called as a function call. This function call takes this variable to the previous function and check whether the function is an prime number or not. So the function call comes to this area and it will take that number from there and bring it over here and check whether the number is prime or composite. Okay, and now so likewise this loop repeats and repeats and repeats until it all the numbers which is required are generated. Suppose we may be asked to generate n numbers, maybe 10 numbers or 12 numbers or 15 numbers. So as long as there are n numbers, you are repeatedly generating the Fibonacci series. So once one number is generated, the function call to prime check is made, and the prime check checks whether the number is prime or composite. So two functions are over. This is the Fibonacci function generates the Fibonacci series, and the previous one is the prime check function, which checks whether the number generated is a prime number or not. Now coming to the main part of the program. In the main part, this is the int main. So integer n, how many terms you want to generate. For example, 1 2 3 4 5 6 7 8 9. When n is equal to 9 terms in the series are generated. Don't confuse with this number 21 here. Okay, here n is the number of numbers to generate. So n integer, n int space n cout. So display on the screen, enter the number of required Fibonacci terms. C in n, get the number from the user, and then print Fibonacci series. This /n/t will give you a tab space, /n/n will give the next line to print. It will print one by one, and then once the display is over, you have to just call the number Fibon. So Fibon, when this is called function call, when the Fibon is called, the function will go to the previous function Fibon, and then it will go to the previous this function Fibon, and then in the Fibon function there is another function call which is like prime check. So when this prime check function call has come, system will go to the prime check function. Okay, like this the flow goes here and there. Okay, so now likewise it goes between Fibon and prime check to generate and check the number is prime or composite. Then after that it will return the 0. So here the numbers are printed. Now how the output will be, number of numbers is 10 you give, the heading has come as Fibonacci series. So first generate 0 and then it generates 1. This all happens from the Fibon function, and then till this 0 1 1 they are neither prime nor composite, and then 2 it is checked with the prime check, it is given the answer comes as prime, and then 3 it is go to the prime check and again it is prime, and 5 generates and go to prime check and 5 it is prime, and when 8 is generated, so this is the series 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, and 13 plus 8 is 21. So 8 is composite because it is 2 4s are 8 is there, and 13 is a prime number, and finally 21 is a composite number because 21 has factors more than 21 and 1. The factors are 7 and 3. So this is how the system generates the Fibonacci series. Okay. Hope you would all understand the logic behind this program. Thanks for watching.